Okay. So, good afternoon, everyone. Welcome to today's workshop on advanced TypeScript concepts. So, before we go to this stage, in our previous workshop, we discussed something very, very important, fundamental, though basic, right? But they are the building blocks of what we are doing or what we are laying on top. So we spoke about installation, if I can still remember, and I believe you all can still remember, how we can install TypeScript and some difference between TypeScript and JavaScript. And we did something like variables, how we create variables, and what makes it different from the type, the data type, that is the fundamentals. And we also did function. Yes, I remember that. Which I thought, and I gave an analogy about how function works. And I use a chat boot, which I did, and we tested, and it gave me a very vital equation. I asked, how do I duplicate a message and type in so that it makes it easier for me since it's the same message? And somebody said I have to copy, and I just keep pasting. And I said this is the same thing the function does. I think with this analogy, I can still remind you what we did on function. And we spoke about the parameters, optional parameters, its values, and so on and so forth. So I believe, and I gave an assignment, which I hope we did. We attempted that, to create a function that adds a number and also the one that says your name. I think so. That was the assignment. I'm still expecting the assignment. All right, so today we're moving further. Some concepts of TypeScript, some things that makes TypeScript unique, different from JavaScript, like your regular vanilla JavaScript. What makes TypeScript exceptional? Why we recommend that you use TypeScript in a large project. So we're learning some concepts, some vital things you need to know. They are also like a basic fundamental of TypeScript. But this helps you to do anything even to proceed. So our advanced terminologies or terms. All right, so we're talking about some advanced TypeScript concepts, few of them. Then I will deeply, I promise that I will be touching, because I'm meant to do the functions and logic. But I said that the logic, before I can teach you logic, you must understand operators, right? Because it lies, this understanding logic means you must understand these operators first. You can't just jump to this without understanding this. So that is why I'm taking operators first, then before we now dive into logic, we'll proceed. I have a question and answer. So I remain your co-doctor, your front-end tutor for DevSoc. All right, so what are types? What are types? So types defines what kind of data a variable can hold and helps prevent errors in your code. So types, when we are doing the basic, I introduced you to data types, and I tell you some data types we have: the string, which for text, the numbers, the boolean, which are set either true or false. Right? So we did that in our previous workshop, and today we'll be moving further to see how advanced TypeScript has made this to be. All right, so I would say that TypeScript defines what kind of data a variable can hold and helps prevent error. So this is very simple thing we did, a snippet of what we did. That you can say a name and provide a data type string. That means it's expected to hold a string. All right, and when you say it's a number, it's expected to hold a number, and when it's a boolean, it must hold the value of boolean, either true or false. So any other option given to it that is not this same data type, automatically TypeScript to give you an error at runtime. It doesn't even wait. We just tell you that there's an error. You can't even proceed. You can't do anything. Once there's error, you keep telling that there's error. It doesn't wait until you run it or whatever. It gives you error immediately. All right. So common TypeScript types, I will just pick up since we spoke: the string, I said string is just your text, the numbers, which is just your numbers, the booleans, which is true or false. So these numbers, the decimal, the floating numbers is also included on this, right? The floating numbers is also included. So the any, this is what the concepts which our vanilla JavaScript takes. It takes up by default this any type, which means if it automatically detect the kind of value you have entered. That's what this is doing. So that means if I did specify the type of string and I'm writing a string, something in a quote, as long as it's in a quote, automatically, since it's dynamically, it will choose the type to be a string and something to numbers and the rest. And also we have this last one, the arrays. All right, so arrays in Typescript, you must also call and identify what kind of elements will be. Data that will be in the element. So these are the elements. So if you say this number, all your elements in this array must be a number. If you put a string in this set of array, you will have an issue, an error. So then this is where it comes in advanced. This keyword type keyword is something that JavaScript does not have. So this is part of the feature that what makes Typescript unique. So the type keyword is used to create a custom name type, a custom name type, a custom name type, a custom name type, a custom name type. So you help to reuse and organize types in your code. So this thing just means, for instance, I have a string. Let's say this is just a string. I think I would like to how it warrants me to share my entire screen. Okay, let's not proceed. So imagine now this is a string, this is a text, right? Or the name is string. I can change this, instead of calling this a string, and call it my text, right? So whenever I want to call string, I'll be calling my text. That is the default name I've given my own. So that is the concept that it will take up that whatever I've assigned and change the name. That is the concept which type is doing, right? Just see it as that way, as basic as that. All right, so type, you can see, how do you specify? First, you call type, you say type, you call the name of the type of the data you want to assign, you put assignment operator, then you put the data type. So what it means that we are not assigning data type to this name. So whenever you call the name, it will get the data type, just like what we did in variable. It's similar like variable. If you understand the concept of variable, this becomes very, very easy, right? This becomes very easy. So this is the type of the name type, and this is the value, which is but the value is no longer a regular value. Though we have an option where we can put a regular text. We'll also do that. All right, we'll move forward. So I will be taking some examples on this type, where you can see how we use it on different scenarios. So the first one is this very simple type that we are using the primitive types. So these are the primitive values, like normal one, all right? So you can see this, let name become string. This is a primitive, a string is a primitive value, all right? Like a normal text, numbers, they are all primitive values, all right? So you can see that we can say this name to be string. And then when I want to create my own variable now, let's say the variable is email, username, and I say take up this data type of name. That means I'm telling him to take up the data type of string, because this string is assigned to name. Then I can only have if it's number and I call it name, it can only take the numbers. You can see that it makes this kind of hidden. So even somebody getting this code, I don't know what kind of data type this guy is accepting until he sees where you have defined the type. That means that tells you that I can actually hide my type of string to make it more secure. I can as well define this type somewhere else, which I can hide it from my code, that kind of thing. Then I call the type here with my default name. So if you can't know the kind of type I'm using until you can see the function, what they are thinking, what made them do this. So I'm trying to give you to get the concept of what is happening before now becomes easier for you to know how to use it. Like you can see the security part, like, oh, I can hide it and nobody will know. Imagine calling name. You don't know whether it's boolean, you don't know whether it's string until you find where have defined it. Alright, so that is what this is doing. That's what it's doing. So you can see note here, say name is just another name for string. You can see name is just another name for string. Just exactly what we are doing. I have reassigned string to call name. So instead of calling string, you can call name. So that is exactly what it's doing. So second example here is the object type. The object type. The object type, we discuss object as a topic, also arrays. But I will give you idea how what this object comprises or how it works. Alright, then you can now understand what we are doing. So I'll just give you instance of how this works. So object is just like a collection of a particular items, their properties. Let's see a human as a property, as a object. All right, inside a human there are different properties like the height, the complexion, the eye color, the height, the color of the hair, and so on and so forth. So you know all properties. So this define a particular object. And you can also believe that another object, another particular human being can still have the same attributes, the same properties of the same person. Okay, now I'll give you instance of, so that once you see this, you also check that most of these properties always comes like an equation. Like if I say a height, okay, that means I don't know the height, I must have the value of the height. If I say color, the complexion, I must get the color of the complexion. So this is the same thing type as object, what they did in OOP, object oriented programming, and they say, oh, we can have model this kind of thing. We have checked that it always have a question and an answer. That means a key and a value, like a property, and there will be an answer. So when you call height, there must be a value. What is the height? When you call complexion, there must be a complexion. That is why we have object to be a key value pair. So you must have a key and have a value. You must have a key, you must have a value. You must have a key, you must have a value. That is what makes up this object as a property. These are the properties. I hope this analogy makes sense. So don't bother much understanding how it's being defined in TypeScript. We will take this as a topic by giving you how it works, what they thought in doing this and how you can use it. Right? So that is it. So you can now start expanding your imagination. But the type object type, we are focusing on this keyword type. So this keyword type says that we can actually perform how we want this object to look like, and any other object can model it. That makes sense. All right, so I can say that I don't actually know who the object it is, right? Let's say we're taking object of human, a person. Let's say a person, object a person, and I say I want to modify this person, how it will look like for me. So whatever I'm using it, the person must exactly look like this. So for instance, and I say the color must be fair, and I say the height must maybe greater than this. Or I may say the hair color must be black, and so on and so forth. So this is the type I have mentioned. So whenever I say this is exactly kind of thing I want, when the person is using it, when I want to actually create the actual use of person user, then I say the height, I must give it exactly that height I have called. If I say the height must be a string, so you must give me a string value. If you give me a number, you have error because that is not the object I say I want. It's just more like custom. I have customized what I want. So it should be like that. This is how I want my car to be, and you should give me exactly how I want it. So you just imagine the same scenario happens in real life. So in programming is just like physics, what you see around you. That is the concept they take in doing programming. Just like your environment. You look around your environment, the same thing that is happening. Alright. So just like a car, I tell a company, I want my car, I want a particular pattern of car. What they won't just jump into doing it. They will first of all call me down and tell me I should describe how I want it. They take note. Alright. So I have already taken note of what this type is doing, how I want my car to be. Then when they start building the actual car, they must fit in exactly what you have specified. That is what is happening. All right, I hope that makes sense. I hope that makes sense. Amy, are you getting it? Amy, are you still with us?
Yeah. Yeah, of course
Okay.
I am.
Okay. I hope you are getting it. Is Daniel here? Rahim, I hope it's making sense. All right. So note this defines the. All right. Thank you. So this defines the structure of an object. The structure, how it will look like. So that is exactly everything I've been saying. The summary of everything I've been saying. It defines the structure of an object. All right. So the third example we take is the union type. So this union type, you also see that is why it's part of logic, right? You get to see this symbol I'm using in logic. In logic, when you have, if you remember your basic or computer, where we have the NOR gate, AND gate, NOT gate, and AND gate, all those, everything, they are logics, all right? They are the logics on the made of the logic gate, all right? So all this also falls under the logic, all right? So we call this union type. So what this union type is actually holding is the OR, which is this sign, all right? The pi, right? This is the pi. But most in Java, we normally use double pi, right? But here we are using just a single pi. This is what it syntax what actually wants to use in this union type, or right, or just a single pi. So what this thing is saying that ID can either be this or this. That's the meaning of or. That's either this or, that means one of them. It must not be two. Or, but if we say and, it means it must be the same. It must be together. Or coming to that. So this union type always say or. So I can actually say this ID, you can give me a text, you can also give me a number. Then I can also add a default and say you can also give me 1, 2, 3, 4, 5 as a default value. And so on and so forth. So you can start expanding your mind. Now when I'm calling this ID, it must be an either number. If I use a string here, I'll also have it correctly because I've said it can be a string or a number. So that's for union types. So I think I say ID can either be string or number. That is exactly what I just explained here. So the ID can either be a string or a number. So number 4, example 4. Please, if you have a question, feel free to maybe call my attention at that point. Or if you don't want to call, you can keep note of your questions after the end of the class. Ask me. But if you feel that you are not understanding, instead of moving forward, call my attention. I will clarify you on that before we move forward, because like I'm building a block. 1, 2, 3, 4. 1, 4 is dependent on 3, 3 is dependent on 2, 2 is dependent on 1, and so on and so forth. So the lateral types. So this is the specific type where you can use the actual type. So I gave something before here that I said you can actually say this can be string, a number, or I can say 1, 2, 3, 4, 5. So this is my a value. So the same thing we are doing this. That's how I'm actually adding these lateral types in it. Right? So I can actually say my status can be either success, error, or loading. So it must be the same thing, and they are case sensitive. Right? Please note. So if I say it must be a success and you are writing capital letter success to be an error, unless I've written a logic to say, okay, even though you have a capital letter, convert it to small letter for me. That's a different case. You are doing different things, right? But this is case sensitive, meaning if I say small letter x, so you must use it exactly the way I've called it. If you say capital letter x, you are calling different types. It's not what this is spied out here. This is spied out here. So that is what we mean by this. And this is using also the or to say it can be either be success. So what we actually mean by lateral sign is this default value, right? It's not you can see here now you're not assigning a data type, whether string, number, type, array, or whatever here again. What you are assigning here now is a normal default string text. Or you say it must be exactly this word, keyword like this. Alright, that's what we mean. So you can say the variable can only be one of those values. So these are the values. So we are using of union type. So next one is the function type. So this function, we discussed first function previous class how we can create a function. Remember how we use the keyword and also the arrow function. So I said that also here we can use the type to specify how I want that function to look like, just like the object, right? So I can say I want this function to be like any function I have. This if you have only 2 parameters, and the first parameter must be a number, second one must be a number. It must return a number. So whenever I'm using it, I just know that if I model this and it must be I must use 2 parameters. I must use 2 parameters here, and yeah, this parameter must be a number, and my result must return a number. So that's how all these things saying. So this define the shape of functions. All right. So next one is the combining types. So combining types is the intersection. Just like I said, so this is just and. The other one we discuss on or. So this is and. So we use just one ampersand. This is ampersand. Right? This is ampersand. The sign. So we use this one ampersand. But for JavaScript, when using this and this must be double ampersand. So we'll come to that. So this is actually defining type. So they use their own syntax. So you can actually combine. So what this thing is doing is just to combine two types together. So I can say person name must be a string as an object. This is kind of object I'm using for an object. I can say the type can be a job, employee. Then I can combine these two. So what happens is just carry this job and place under below this name, just like you can see it here. So these two joins together to become one. That's what we are doing. That's what we are doing in this combining types. So next thing we will discuss is interface. So they are kind of related. The type and interface is kind of related. They are also the same doing creating a structure. That's the same work they are doing. They are doing a structure. That's what both of them are doing. So this defines the structure of an object and ensures the object follows a specific format. So it's the same structure we are doing, but this actually works for objects or mainly for objects and classes. You can't use this for primitive types. You can't use for primitive types like the string, the whatever we have discussed primitive. So you can't use it there. So this, what do you define this for the type? When we're using type, we say type, the name of the type, assignment operator. But in interface, say interface, the name, and you can see the name. Then you don't put the assignment operator here. Don't put any equal to here. Then you just put the curly brace. This is mainly for object or for class. And the same thing we are saying. So we are saying this is how I want my string to be, my object to be. The name must be like this, and I just come and use it here, and it must be like that. So this type versus interface, say type is more flexible. The type is more flexible, can handle union, primitive, and many more. Alright. So the interface mainly used for object, classes, and extension. That's what we use it for. So operators in Typescript. So now let's talk about operators. So we have actually finished the concepts, the basic concepts of Typescript. We'll be discussing type and the interface. That's very, very important. As we proceed, we'll be introducing some more. Alright, so that kind of advanced, but the two you cannot run away from. Just like these are your basics, the type and interface. You must know them very well and how to use them. Very important. Alright, next one is these operators in Typescript. So what are operators? So operators are symbols used to perform operations on value, just like a plus, a minus, equal sign, modulus, or and, right? So just use to perform an operation. What we can use to add the attest to this left value and the right value, and something will happen. So these are all operators and kind of a symbol. So they allow you to calculate, compare, and make decisions in your code. Alright, so types of operators. We have the arithmetic operators, we have the comparison operators, we have the logical operators. You can see where you're falling in logic. We have the assignment operators, and we'll be taking them one after the other. So the first one, the arithmetic operator, I won't waste so much time because I know we have done this in our basic schools. From primary school down to your tertiary, you always do this. You use for mathematical calculation. So use the plus for addition, the minus for subtraction, multiplication, division, modulus for remainder. Right? So you can see how we use it. The variable assignment operator bring these values upfront. You can say 10 modulus 3. So the remainder, the 10 divided by 3. After dividing, what will be the remainder? So you have 3 remainder 1. Right? So you pick the remainder. That is what we are doing here. So comparison operators. So this is used to compare values. The comparison is what we use to compare whether this is equal to this is bigger than this is smaller than this. They are all comparison. And we are done with our basic equal. Is this equal to this? Is this greater than this? But when we say left, when you do your left is less than, when you do your right is greater than. So we have done this from our childhood. Alright, so these are that's that we are still just taking the same thing we have learned. It's nothing difficult. So we say in JavaScript syntax, want to do equal to check if something that they are both equal. You use either the double equal or the triple equal. Please confirm if you can see my screen. Huh?
Yes, sir.
Okay, thank you. All right, so the double equal or the triple equal. So one is loose and one is straight. Right, so I'll just quickly speak on this. Why one is loose and one is straight. So what this guy is doing, this one does not change the data type. I can actually say 5 is equal to string of 5, and this one will tell me true. So note, all these comparison values always return a boolean value, either true or false. Any comparison value, it will always return either true or false. It will always return a boolean value. Please know that. Alright. So if you say this 5 is 5 the same thing as 5 of string, this one here we say true because it's not checking data type. It's just saying 5 5. It's true. But this street we say no. They are not the same type. This is a string. This is a number. You can't compare. You can't say that number is same thing as a string. So that is what this one is doing. So not equal is checking if it's not equal. So if you say this one also have weak, the loose and the straight. So this single equal sign is the loose and double equal sign is the straight. So if you say this weak not equal, it will say false that they are equal. But if you say the straight not equal, it will tell you yes, they are equal, true that they are equal. I hope that makes sense. And this last one is just your greater than, less than, greater than equal sign, less than equal sign. I believe that is fair. All right, so I will do a little more on this before we round up. So the logical operators. So the logical operators is used to combine conditions. So you can see just same thing I said, this intersect and this is the union, right? So this is kind of the or, this is the and, double ampersand and double pi, and this one is not. So this one says, the rule for this one says that all the conditions must be true before they are true. All right, so that is what this one is saying, that all conditions here must be true before all is true. For instance, I say, Hemi, buy me water and meat pie and pen.
I think everything happens for a reason.
And you went there and buy meat pie and only pen. You didn't complete my message. I will mark you 0 because you didn't complete. I said, and that means I'm expecting to get 3 of them. But if I say, hey, buy me a meat pie or egg roll or buns, if you go there and buy me only buns, I will mark you good because I gave you an all option. Now anyone that is available, get it for me. So that is the analogy what this thing is saying. So if you say this and, it means that all the conditions must be correct, must be true before you can get through. Otherwise, you will get false. If I'm to mark you, I say buy me meat pie and water and pen, and you buy only 2, I will mark you false. This will say false until all of them is completed and I say true. But for this all, once one is true, you just say true. But all of them, if all of them is not false, it's only when you say false. Then this not say opposite. So if something is not true, it is false. If something is not false, it is true. That is what we are saying. So you can see true and false, since all of them must be true for it to give you true. So once you have true and one is false, automatically we are having false. So all must be true before we can get true. All right, I believe that is clear. So the last thing we will check is this assignment operator. So this is exactly what we've been doing to assign. So equal sign is just trying to assign the value from the right to the left. And this one is saying it will add and assign. This one will minus and assign. This one will multiply and assign. And it will call this incrementers. All right. Incremental, increment, and so on and so forth. So you can just see it. That's what it's doing. So if S assign 5 to it, we say increment it by 5. You just take off 5 and add 2 and reassign it to S and produce 7. All right. So I think that will be stopping for today. So any question? Question time. Question. Emmy, Remy, Danny. How are you doing?
No question for my.
And we make it simple and also advanced. All right. So do I use the word at average from languages, like when you're writing maybe Python or they're writing JavaScript, right? In JavaScript, we call it array. Python also call it list. Both of them are doing the same thing. But in most compiled language, they are two different things. Right? Why is that? They both assume the same behavior, like a C#, C++, and so all those heavy language, the compiled language. All right. So what they do there is that they say array is a fixed size. That means if you are defining an array, you must tell us the number of elements that will be in that array. So if you want to define an array and you just want to take the student record, you must tell me the number of your students. So you must say the student is 100. So anything bigger than 100, you don't enter. But list gives the option of having dynamics. So even though in the future I want to say it's 1,000, you are allowed. So that is how they differentiate it. But they are all doing the same thing. Does that answer your question, Mario? So I'm back to Rahim. Rahim says from our own end, everything is clear. And I'm asking, Rahim, does it mean you understood? Because
No,
I
sir.
want to blow horn for you. You say yes?
No, sir.
So what is the question? So ask your question.
Sir, can you please go
Ask your
back to
question.
the string part?
Okay, can you see the screen now?
Yes.
Go back to what?
String.
String. Okay, with this string in that should be beginning now.
Yeah.
From here.
Yes. Sir, the code.
Okay.
Sir, that's an array, right?
Yeah, this is an array. So what we did
Sir,
here
is
is
it
you're
only
saying,
numbers array is used to store?
okay, I didn't hear you. You said what?
Is it only numbers that you make use of array?
Exactly. That is what that type is telling us. So you say these scores can only have a type of number array. So it must really be number. So if I say string array, it will really be string. So if I want it to be dynamic, I can use the union. Say number or string. Then I can use the number and I can also use the string.
Okay.
But if I didn't specify this, I didn't put this and this type in the any type, this any, so it will by default just assume what, but we don't recommend it since we are using TypeScript. It's only vanilla JavaScript that will be using this for just simple projects, right? So, but if you don't specify it, you just take the normal vanilla JavaScript pattern, any, it's the any type. Then you cannot add anything that you like. So by default, choose what you want. Does that make sense?
Yes, sir.
Any other question?
So I'll go to the boolean operators.
Boolean.
Yes.
Boolean. This is okay. That is comparison operators. That should be comparison.
So yeah. So 5 equals to 5. You said false. Why is it false?
All right, that is what I explained. This is strict, and this is loose. Loose we say true. Strict because it's 3 equals, and look at what they are writing here. 3 we say false. Why? What is this? What other type is this? I mean. What other type is this?
Which one? The one that you highlighted.
Is it Hemi? Sorry, not Hemi. I'm asking Rahim. Sorry, not Hemi.
Oh.
Yes, this one I'm highlighting. Rahim.
No,
what other
number.
type is this?
Number.
What other type is this?
Number.
Is this a number?
No, it's a string.
This is not a number. This is a string because of these quotes you are seeing. So anything inside a quote is a string. Be it a number that you are seeing with your eye. Code will say this is a number. How our code detects that this is a string is that whatever inside this quote, it doesn't even actually know if it's a string. You just check after you are in this quote, you are a string.
Okay.
Are you understanding that? So this one we say, oh, I don't even care about data type. I don't care if you are in a quote. I'm not checking the value. Oh, this is 5, this is 5. They are the same. But this split one we say, I want to check your data type first. Oh, this is 5. You are in a quote. This is string. Automatically, you are not the same. Oh. Are you getting it?
Yes, sir.
Just another example. We want to check boy and boy. All boys by default are the same, but we want to group them by family. My own boy in my family and your own boy in your family, are they the same?
No, sir.
All right, that answers the question. That is it. Any other question?
So now what about if it's like the first part is BOY, capital letter B, then we now have the 2, then we now have small letter BOY. Will it be true?
If what?
If we have BOY, but the B is capital letter, then equal.
All right, go ahead. I can hear you now.
Okay. So if you have BOY, boy, but the B is capital letter, then we now have the first equals to, that's the 2 equal. Then we now have BOY, but it's not small letter. Will it be true or false?
No, they are not the same. They are different because they are JavaScript or TypeScript are case sensitive. So that is a different rule.
Okay.
They are both strings, but they are not the same case. It's not be true. Both the weak and the strong will mark it wrong. As far as that is a general rule that they are, when you hear that it's case sensitive, it means that from default they are not the same. You don't even need to check anything. Small letter B and capital letter B are different by default.
Okay, sir.
All right. Any other question?
No, sir.